Hello learners, and welcome to today's lesson of exponent law number 5 and scientific notation. Let's start off our lesson with a did you know. So, did you know that exponents make it easy for us to write very big numbers? For example, 2,360,000,000 is equals to 2,36 times 10 exponent 9. Let's see how this is done. So we are going to, by the end of this lesson, know how to calculate powers that are raised to an exponent 0 without the use of a calculator, expand numbers represented in scientific notation, write and represent numbers in scientific notation. So that's what our lesson is going to be about today. Let's look at our concept map for today's lesson. So we are going to be working on the fifth exponent law, which is raising a power to an exponent 0. Then we are going to be working with scientific notation. And then lastly, we are going to end off with some problem solving. So what you must know for this lesson. So you must know and apply the following exponent laws: multiplication of powers of the same base, division of powers of the same base, raising a power to a given exponent, raising a product to a given exponent, and raising a quotient to a given exponent. So these are the exponent laws that we've already looked at in previous lessons. So this is just a reminder of those laws and how they work. So remember, when we are multiplying exponents of the same, when we are multiplying powers that have the same base, then what we do is to add those exponents. When we are dividing powers of the same base, then what we are going to do is to subtract those exponents. Now, when it comes to raising a power to a given exponent, then those two exponents are going to multiply. Then, when we are raising a product to a given quotient, remember the exponent that is being raised will multiply with the exponents that are within the product. And that same applies to the quotient. When we are raising a quotient to a given exponent, that exponent is going to multiply with each exponent in the quotient. Let's look at this practically. So we are going to look at some examples here. So the first one here says 2 exponent 5 multiplied by 2 exponent 2. So how are we going to work with this? Remember, we are multiplying powers that have the same base. So what did we say we do? We keep the base and we are going to add those exponents. So we are going to have a base 2. At the exponent, we're going to have 5 plus 2. That is going to give us 2 exponent 7. What about this next one here, where again, we are multiplying 2 powers that have the same base. Now, remember, it's negative 5 exponent 3 multiplied by a negative 5, and that exponent there, remember, is a 1. So what are we going to do since we are multiplying powers that have the same base? Then we are going to keep that base, and again, we are going to add the 2 exponents. So that is going to give us a final answer of a negative 5 exponent 4. What about when we are dividing powers of the same base? So we are going to keep that same base, and then we are going to subtract the exponents, and that is what we do when we are dividing powers of the same base. So in this case, we have a base of 7 and the exponents are 4 and a 3, so we're going to say 4 minus 3, and that is going to give us a final answer of 7 exponent 1. Remember, 7 exponent 1 is equals to 7. Then we have here a negative 11 exponent 3 divided by a negative 11. Of course, that negative 11 has an exponent 1 there. And because we are dividing powers that have the same base, we are going to say there that it's a negative 11. We are going to subtract those exponents. So that is going to be a 3 minus 1, leaving us with an answer of negative 11 squared. And that is just a reminder of those exponent laws. Let's look at more of those laws. So here we have a negative 5 raised to the exponent 4. And that power is raised to an exponent 3. Now what we do when we have raised a power to an exponent, remember those exponents will multiply. So we are going to have a negative 5, and then those exponents, the 4 and the 3, are going to multiply together, leaving us with an answer of a negative 5 raised to the exponent of 12. What about this next one there? We have a negative 12 raised to the exponent 3. Well, firstly, we can then now factorize that negative 12. We know that negative 12 does come from a negative 3 multiplied by a 4, or we can write it as a 2 squared, because 2 squared is a 4, and that is all raised to the exponent 3. Now this is a product that is being raised to an exponent. So what happens with a product that is being raised to an exponent? Well, each of the factors in the product will multiply, each exponent within the product will multiply with the exponent that has been raised. So that means that that 3 will multiply with that 1, giving us a negative 3 exponent 3, because 1 times 3 is 3, and that is going to be multiplied by a 2, and that is going to give us an exponent 6, and that 6 comes from us saying 2 multiplied by that 3, and that is going to be our answer for that one. And then lastly, we have this one here where it is a 3 divided by a 4 squared, and this quotient is now raised to the exponent of 4. So how are we going to work this out? Well, firstly, that numerator 3 has an exponent 1 there. So we are going to take that numerator 3 and we are going to make sure that those exponents multiply with each other. The same is going to be done in the denominator, where we have the base 4, and that exponent 2 is going to multiply with that raised exponent of 4. What is our answer going to be? That is 3 exponent 4. That 4 comes from 1 times 4, and that is going to be divided by 4 exponent 8, and that 8 comes from the 2 times 4. Now remember, are we going to now subtract those two exponents because we are dividing two powers? Absolutely not, because those powers need to have the same base in order for us to be able to subtract those exponents. So that is our final answer right there. Let's look at the keywords that we are going to be looking at in this lesson, and that is, for starters, scientific notation. That is a way of writing numbers that are too big. Now, for example, 150 million is written as 1,5 multiplied by 10 exponent 8. Then we have expanded notation. That is a way of writing a number to show the value of each digit. Now, for example, 3 multiplied by 10 exponent 4 in expanded form is 30,000. So those are the keywords that we are going to be looking at in this lesson. Let's quickly go for an ad break and then we'll see you just now.